we're going to start getting into what I like to think of as practical calculations with electrochemical cells, such as how much energy do you get out of this thing? How long will it take you to charge your battery? And also, how much will it cost? How much will it cost you to charge your battery? So we can calculate all of these things based on the equations that we've discussed, which is pretty cool. So I'll remind you, a standard cell potential, or really for that matter, any cell potential, right, in voltage equals joules per coulomb, which is work per charge. We remember work can be rearranged to be charge, which is in units of coulombs, times cells, okay? But now we have to kind of start thinking our way through some other common units that we see with power and electricity. So one of those is the ampere, or colloquially known as amps, okay? And an amp is a rate of charge. So that's 1 coulomb per second. And so if you've heard the phrase, it's not the voltage that kills, it's the amperage, that's true. And that's because that is the amount of voltage you're getting per unit time. So it is a rate of how many electrons are flowing. And of course, we could rearrange this and say, well, then a coulomb is just an amp second. We recognize a volt as a joule per coulomb. So we haven't talked about watts in this class, but you did briefly in Chem 109. So a watt is a unit of power. So let's actually write all these down. Power, let's see, rate of charge. We know the coulomb is charge, and we call this voltage, we call that potential, okay? It's your energy per charge that you have. So we know the watt is power, which is 1 joule per second, and more commonly, we see, like in our power bill, for example, kilowatts. So 1,000 joules per second, okay? And so if you paid attention to your power bill, your PG&E bill, you might have noticed this crazy looking unit, the kWhr. So that is called a kilowatt hour. So what is a kilowatt hour? Well, if we play around with all of these units for just a moment, okay, we can do some dimensional analysis. So 1 kilowatt hour equals 1,000 joules per second per hour. I can't write. So in other words, it's the amount of power you're using multiplied by the duration of time you are using it. Okay? And so if I keep going down the line here with my dimensional analysis, so we know that in 1 hour, there's 3,600 seconds. So that comes from 60 times 60, 60 seconds in a minute, 60 minutes in an hour. And so you can see when we do that, the hour cancels, and the second cancels. And when you multiply 3,600 by 1,000, that gives us 3.6 times 10 to the 6 joules, which is the same as 3.6 megajoules. Okay? So the kilowatt hour is a unit of energy. It's how much energy you use. And I just looked this up. So PG&E, the average for this past year for PG&E was 19.9 cents per kilowatt hour. So in other words, for every 3.6 megajoules of energy you use in your home, apartment, whatever, it's costing you roughly 20 cents. Now, I know that that doesn't sound like a lot, but so for example, in my house, I'll tell you right now, we average around 450 kilowatt hours per month is about what we use. So now if I multiplied that by 450 kilowatt hours, and of course, like this is not, maybe some of you are aware that there's like time of day usage, right? Like you get charged more depending on what time of day you're using your power. So that all depends on if you're using power in the evening or in the morning, etc. But 19.9 is a good average from PG&E's website. And if I multiply that by 450, Oh, and that's 19 cents. So of course I've got to divide it by 100 because I was like, I don't spend $9,000 a month. So there we go. So that is then roughly $89, 90 bucks a month for 450 kilowatt hours. So that's a good average for us. In the winter, I think it's more like around 200 bucks. And in the summer, it's probably more around 50 bucks. So it varies quite a bit depending on how much power you use and when you use it. But I think it's good to know these numbers as an informed consumer, right? Being able to predict like what you're spending on power. And that will allow you to assess one day, maybe I should get solar panels or an electric car, right? And you can start working out how much that would cost, which is pretty cool, okay? So I want to talk about the nickel metal hydride battery. So we've already talked about alkaline batteries, and alkaline batteries are your single use, AA or AAA. So as it turns out, if you reconfigure the anode and cathode of these things to be what they call nickel metal hydride, then they are rechargeable. So you can use these as both voltaic cells and electrolytic cells, so they can be reversed. Okay. And I would highly recommend you go this route to save money. You'd be amazed how expensive batteries add up over time, especially if you have a child who has toys and leaves them on all the time and drains those batteries like every day. It's expensive, and it's actually environmentally detrimental to chuck those old alkaline batteries, okay? So this is my PSA announcement. Switch over to rechargeable batteries. You will thank me, even if you only get like 10 recharges out of them, let's say. You're saving 10 times the amount of money you would if you had to buy 10 rounds of non-rechargeable batteries. So these are absolutely worth it. They are good for the environment, and we're going to do some calculations and talk about how they work. And I'm going to record that in a second part of this video.